Pre-lesson 1-2, section 1-2. As you can see, they're going to make a clean break from all that stuff in the previous lesson, and now they're going to build you up with your basic algebra. So again, forming the foundation so that we can build on it later. Here we go. See if you guys remember these. Pretty simple. When the bases are the same and you're multiplying, what do? You add the exponents. Now, if I actually put a number in there like this, somebody's going to want to say 2 times 2 is 4. And that would be wrong, because notice the base did not change. The temptation's there when there's numbers. But the rule's still the same. When the bases are the same and you're multiplying, you just add the exponents. You don't change the base. This one, when you raise a power to a power, you multiply. This one, there's a couple variations of this one. Most algebra teachers teach that you just subtract the bottom from the top, and you get x to the 5th. I like to throw a little spin on it and just say, okay, where's it warmer? Is it warmer upstairs or downstairs? Think of this as 7 degrees, 2 degrees. Well, it's warmer upstairs by 5 degrees. So that would be my answer. Now, why is that beneficial in any way? If you had a problem like this, x to the negative 3, x to the negative 2, notice there's negative exponents going to be taught in a few seconds. I'm going to come back to this in a second after I show you the negative exponent lesson. So 3 cubed, what is it? 27. 3 squared, 9. 3 to the first, 3. Notice the pattern. Divide by 3, divide by 3. So that tells me what to do next. Divide by 3. 3 divided by 3 tells me the answer to this next problem. And there's a golden rule. Anything to the 0 power is not 0, it's 1 because of this. Now, if we kept going, we would have to divide this by 3 to get our next answer. Notice my pattern, 3, 2, 1, 0, negative 1, negative 2. This is what teaches us about negative exponents, because 3 to the negative 1 power, I'm going to slide the negative over here. Just forget about it for a second. It means take this and put it in the denominator. So the real problem is 3 to the negative 1 power. So what about this one? What does this negative tell us to do? It tells us to put 3 squared in the denominator. I always say it's an instruction to tell us put it where it ain't. So with that in mind, let's go to this, and then we'll get to the negative exponent in a minute. This is just a simple problem. What's anything divided by itself? Well, that's 1. This is like 7 over 7. We know it's 1, so you could just say, hey, that's 1. But let's do the math using this rule. 2 minus 2 would be 0. Anything to the 0 power is 1. Just another little reminder, anything to the 0 power is 1. Let's get to these negative exponents. So what does this negative mean? It means put everything else where it isn't or where it ain't. Done. Now here's a tricky one. Do these two negatives cancel? I know you've been taught a negative times a negative is a positive. That's not what this is. This is saying put everything where it ain't. So if this is a fraction, we would just flip it. So we'd get 3 over negative 2. Now, typically in math, you just keep the negative in the numerator, so we'll just put it there, and that's it. Now, what about this thing? Well, again, you could stick with the rule. You take the top exponent, subtract the bottom one, that's subtracting a negative, and that would be x. That'd be negative 3 plus 2, which is negative 1, which means 1 over x. Now, what's this whole temperature thing about? Well, it saves you a little bit of time. You don't have to do this, but you got to think now. Upstairs, it's negative 3. You've got some super, super down blankets on you if you're sleeping in that. That's upstairs. Downstairs, it's negative 2. Where is it warmer? Not by much. It's warmer by 1 degree in the denominator. That's why you could look at this and go right to here. It's warmer in the basement by 1 degree. That's my answer. That's the way I like to do those now. It's just a little less work. Okay, that's a good warm-up. All right, continue. So we got the square root of 49. Now, there's a lot to this. but I'm just going to keep it simple. We know it's 7. Now let's act like we didn't talk about that. Let's talk about some parts. That part right there is called the radicand. This little roof here is the radical. Now, for example, if we just look at the x, just x, there's an invisible one there, and there's an invisible coefficient there. There's a lot of invisible things in math, and there's one other invisible thing here, and it's called the index. Now, if I had you read this, you'd say the square root of 49. Where's the square come from? Well, there's an invisible 2 right there in that little crease. So that's asking you what number times itself twice is 49. That's why our answer is 7. Now you guys might say, well, negative 7 is also, I know, but we're just going to stick with what's called the principal root, the positive root. So with that in mind, what's 7 squared? Well, 7 squared is 49. Well, why am I showing you this? Because these problems are going to force you to understand some rules here. So let's talk about this. What is this? That's the radicand. What's that? That's the power of the radicand. This is the radical, and there's an invisible 2 right there. I'm going to make it dotted. Now here's how you're going to handle these problems. And you're going to slide the radicand over and do nothing and build a fraction. The power of the radicand goes in the top. The index, I'm going to make it dotted so you know where I'm getting these 2's from, goes in the denominator. So don't forget, this is your index. So what does that reduce to? 7 to the first. What's that? 7. Now, is that the way I would do this problem? Not in a million years. I would go 7 squared is 49, the square root of 49 is 7. So why am I showing you this? Because of these. So this is called radical form. They're going to want you to write it in exponential form. So you take the radicand, slide it over, power of the radicand, numerator, index, denominator. Then they're going to have you sometimes take this, which is called an exponential term or expression, and they're going to have you write it in simplest radical form. So we're like, okay, that's my radicand, that's the power of the radicand, that's my index. All right, I'm going to build some more on that in 2 seconds. Now we're going to actually apply that to an actual math problem. We're going to say, all right, simplify. Okay, this is a number raised to an exponent that's a fraction. So based on the example number 6, that's the radicand, this is the power, this is the index. Now I'm going to show you guys something. On this one, I'm going to do this first. So that is just the cubic root of 64. I know you guys have seen the square root of 64 1,000 times, which is 8. But this is asking you what number times itself 3 times is 64. Well, 4 times 4 times 4, guess what? Is 64. So my answer is 4. Now, why do I have this written up here again? Well, let's experiment. Let's do this first. Well, that means I'm going to find the cubic root of 8 first. Well, what number times itself 3 times is 8? Well, 2 times 2 times 2 is 8. So my answer to that would be 2. And now I got to square that, which is 4. So take a look. Did we get the same answer with 2 different techniques? Yes. Now, if these numbers get huge, you definitely want to go this way first, because you want numbers to get smaller before they get bigger. But both work, but definitely head this way, okay? So the author is definitely taking it back to like pre-algebra, algebra 1, algebra 2. You've seen this a lot. Never goes away. Finding equations of linear, that means line, which means y equals mx plus b, which means we need our y-intercept and our slope. So I've spoon-fed you the easiest possible one just to build your confidence and just see where this is going. Find an equation of a line with, look at this, slope 2/3. What's that? That's saying m is 2/3. Y-intercept is 6. What's that? B is 6. Just put it where it belongs. So y equals mx plus b. Cannot get any easier than that. Okay, so now they're not going to spoon feed you quite as much, and you have to know how to react. So find equation of a line with slope 3. It's like, okay, there's my slope, m. So I know this much, 3x plus b. Now look at the difference. The previous problem spoon-fed you the y-intercept. This just tells you a point that it goes through. So if I actually took a little picture, 1, 2, 1, 2, 3, 4, it would be like right there. And slope is 3, so that'd be 1, 2, 3, like 1. So it kind of looks like this. Now my drawing's not perfect, so I got to figure out where my y-intercept is. Well, we're not going to use our graph to figure that out, because nobody graphs perfectly, especially if it's a decimal. Like, what if your y-intercept's 2.19? You really going to be able to eyeball that? So we need to use some math. So here's my x, here's my y. We're going to plug that in here. Y equals mx plus b. This is 6, so I'm going to subtract 6. B is -2. Now, if I looked at it, you know, maybe it would go down a little bit like that, and it looks pretty accurate. But I take that -2 and put it right there. Y equals mx plus b. One more, and they're going to give you less information. All right, so what are the two things we need? Slope and y-intercept. This problem gives you neither of them. So, basic math 101, we're calling that x1, y1, calling that x2, y2. Hopefully you know this formula, slope, pretty well. And here we go. So y2 is -2 minus y1 is 2. x2 is 4 minus, careful, wait a minute, x2 minus x1 is 6. Okay. So we get -4 all over -2, which is 2. Now, if this was given to you in a picture form, 1, 2, 3, 4, 5, 6, 2, and 4 -2 would be right about there. We can see our y-intercept is going to be down here somewhere. How are we going to find that? Well, we found our slope, so we're going to fill at least that part in, and then we got to get creative to find our b. Notice we have 2 points, point 1, point 2. We can pick either one of them because the line goes through both of them. Plug them in here. I'm going to pick the first one. Y equals mx plus b. Now this is 12, so I'm going to subtract 12, subtract 12. I get -10 is b, and that makes sense looking at my picture. So it'd really be 2x minus 10, or plus a -10, however you want to answer it. So those are the 3 levels of those kinds. So if you're feeling pretty confident, don't skip the example problems because there's a few different things that I show in the example problems. I don't pack it all in the pre-lesson. This just kind of gets you going. So watch that example video.